Hi, my name is Jeremy Shaw, and today I'm going to be doing a little live coding to show you how easy it is to create a pasteboard application using happstack-foundation. Happstack-foundation is a new library which builds on top of existing components to provide a powerful and type-safe environment for web development. It uses 5 key components: happstack state for the underlying HTTP support, HSP for the HTML templates, web routes for type-safe URL routing, reform for type-safe form generation and validation, and acid state for persistent data storage. So let's get started. The first thing we need to do is create a directory for our project. We're going to call our pasteboard ControlV, and I'm going to touch the main.hs, and I want to create a .cabal file, otherwise the GHC mode will get a little bit confused about where everything lives. So we can use cabal init for that, and I like to use the -m option, otherwise it puts a lot of comments in the file and I have to delete them all by hand. So package name, yes, we'll make it BSD, my name, no web page, yet another pasteboard. This is a web application. It is an executable. Great, we're done. So now we can edit the main.hs. Apparently I have another one of these open somewhere, so let's kill that. Alright, so first thing we need to do is add a bunch of language pragmas. I'm not sure entirely which ones we will need in the end, but we're definitely going to need derive data typable, generalized new type deriving, overloaded strings, that one's usually good. We're definitely going to need a little bit of template Haskell, hopefully not too much. We're going to want record wildcards. You may not be familiar with this extension, but it's neat and we'll see that later. The next line you have is a little bit unusual. We need to run a preprocessor over the source code in order to make HSP do its thing. And this is what the line looks like. Basically it says we want to pass an extra flag to GHC. The -F says that we want to run a preprocessor, and the -PGMF says what program that preprocessor is, and in this case the program name is TRHSX. So it's not too exciting, but it's a little bit weird if you haven't seen it before. So, So now we're going to import happstack-foundation. We're going to use ixset in this project, so we'll import that now as well. That's all I can think of off the top of my head. We'll probably use data.text, so we'll import that. We'll probably need to use some function for it, so we'll import it qualified as well. Alright, so for our pasteboard, we're going to keep it really simple. We want to be able to view the most recent pastes, we want to be able to add a new paste, and we want to be able to view a specific paste. So the first thing I like to do is create a model of, I usually find that to be a good starting point, so we're going to create a little model. So let's make that now. Because we're going to use acid state, we can just make Haskell data types and everything will be pretty straightforward. So the first thing we're going to want to do is create a paste ID to uniquely identify each paste, because we're going to be able to link to individual ones. And we'll derive everything under the sun. Oops. In bounded We need the data and typable instances for acid state and IX set. And then we also need the safe copy instance here. Safe copy is a library for doing binary serialization with version migration. So it actually builds on top of the serial library, which is very similar to the binary library. The primary difference is that it actually records a version number with the data, and if you change your data type later, you can actually provide a migration instance to go from the old version of the data to the new version of the data. So we're also going to do a derive path info on the paste ID. This will allow us to embed paste IDs in our URL when we get to that. So we'll just put that in now. Usually in pasteboards, you can input stuff in like syntax highlighting or markdown or any sort of fancy things like that. So we're going to need some way to record what format the post is in. But right now we're actually only going to support plain.text because supporting anything else is really not interesting from what we're trying to learn today. And so we'll add all of the same, well, most of the same instances again. Typable. We'll leave out enum and bounded right now because even though that would work now, it's possible that some formats may not support those, so we don't want to support them now and then revoke them later. We also need a safe copy instance for this. When we declared the paste ID up here, we just did deriving safe copy, and we could do that because it's a new type and we just used the generalized new type deriving extension. But for this algebraic data type here, we actually have to, the new type deriving stuff is not fancy enough, so we actually have to create we have to use a little bit of template Haskell code to create this instance instead. In essence, it's doing the same thing as the deriving clause would do if the deriving clause could be extended and was a little bit more powerful. So the 0 here just means that this is the 0th version of the data type. Base means that it is basically the first version. It's the oldest version that we're going to support, in this case the first version. If we change this type later, instead of being base, we would say change the version number to 1, and it would be an extension, meaning it extends a previous version of the type. And then format is just the name of the type we want to derive save copy for. So it's a little bit of template Haskell magic, and I know some people don't really like that, but as the name suggests, it's not really fundamentally any different than doing these derivings that we do up here. It drives a bunch of really generic boilerplate code, and 99% of the time you don't want to write it yourself because there's nothing interesting going on there. So next we'll create a data type for the actual paste. We're going to split this data type up into two pieces, the metadata for the paste and then the actual body of the paste itself. And we want to do that because, for example, on the page where we list all of the recent pastes, we don't need the body of the paste, we don't need the body of the paste, but we do want to know the title and the author and the time and things like that. And so this will make it easier for us to get just that meta information without getting the entire paste itself. So it's going to have a paste ID that uniquely identifies it. We're going to make our paste have titles, and they'll just be text. We'll make this a person supply their nickname. We need to know what format the body is in. And then we want to be able to show these in reverse chronological order. So let's put in a time that it was pasted as well. And once again, we're going to derive a bunch of things for it. Eq, ord, read, show, data, typable. And we also want a safe copy instance for this. So same boilerplate as before. And we need to import the time stuff as well. So UTC time, And eventually we're going to need to get the current time, so we'll just import that now. So let's see if we have any mistakes. Wow, we got a mistake really early on here. Module main. No instance of bounded integer. Oh. Yeah. We'll leave out bounded then. It of course makes sense that there is no bounded integer instance because an integer can go on forever. So now we'll create the actual paste type, and it just has two paste records. It's got the metadata, and it's got the actual contents of the paste. And drive equal E. All right. So those are our, now we have all the types for actually describing a single paste, but we're going to have a whole collection of pastes. And for the collection type, we're going to use ixset. Ixset is sort of a cross between a set and a map. It's basically a set type that supports indexes, and unlike map, which only supports a single index, an ixset supports as many indexes as you want to create. So in this case, we're going to want two indexes. We're going to index that allows us to retrieve a paste by its ID, and then we're also going to want to index on the time that the paste was submitted so that we can get a reverse chronological sorting of the pastes. So to do that, we need to create instance. I need to create an instance of indexable for paste, and it only has one function, the empty function. And the empty function, so ixsets are a little bit weird in that the functions that generate an index are actually stored in the ixset itself and can actually be changed at runtime. So here we're going to define how to create an empty ixset, and part of creating that empty ixset is, even though it has no values currently stored in it, we do still have to tell it the functions to generate the indexes when you add new values to it. So these are just some helper functions. So ixset, we're just creating an ixset. Ixfun says that we want to actually manually supply the function to generate an index. There's also an ixgen or something like that, which uses generics to automatically extract keys by their type. But the ixfun stuff will give us better performance and more control. So for the paste ID, we're going to have a little function like this. It's a little confusing to write it in infix notation, so let's actually spell this out. So let's say we have a paste. We want to extract the list of paste IDs from that paste. There's only one in this case, but for some types of keys, you might actually, a single value might produce multiple different indexes or keys. So we need to return a list value, and we want to say paste ID, paste meta, paste. So we need to close this. So we can write it like that. That spells it out a little bit more clearly without all of the pointless stuff, but actually in general, once you're used to reading the pointless stuff, I think it's a little bit easier to read. Plus, I really like the monkey operator. All right, so we also said we wanted to sort by time, so we'll put pasted and paste meta as well. So now that we have an instance of indexable, we can actually create ixsets of paste. So the next thing we're going to do is create a record that holds all of the values that we want to store in acid state. And we don't really have many. In fact, we only have two. We want to hold the ixset that has all the pastes in it. And we want to we want a record that tells us what the next unused paste ID is. Now this is kind of an annoyance. Unfortunately, ixset does not support auto increment function, so we have to sort of implement that ourselves. That's really just a big shortcoming of ixset. Somebody should be able to add it if they were so inspired, but nobody has stepped forward to do it yet. But that would be one of my top 5 wish list features for ixset, is an auto increment functionality. So the next thing we're going to do is create a value that we will use as the initial value for acid state when the application first starts up and there's no previous state. So the first time it runs, what should the state be? Missing the capitalization there pretty consistently. All right, so initially our set of pastes will be empty, and the next paste ID is going to be paste ID 1. So we're skipping paste ID 0 because we're going to use that later, where paste ID 0 means that a paste ID hasn't been assigned yet to a paste. I'm actually not entirely thrilled about giving paste ID special, or paste ID 0 special meaning without it being enforced by the type system. But it seems to do the job. I haven't actually run into problems doing that in practice, so it's more a philosophical dislike than something I've actually encountered in practice. So now we want to make our acid state events that will actually modify our database. So we're going to need a function to add or update an existing paste, a function to get a paste by its ID, and a function to get all of the recent pastes. So these are going to be acid state events. Acid state is basically a native Haskell database persistent system. There's a lot of ways to describe it. It's a little bit hard to describe it all in one sentence. But the simple model you could sort of imagine is if you stuck all of your data inside of an mvar. That's sort of how acid state works, except there's a bunch of regulation around it that ensures that you get all of the acid properties, that an event either completes entirely or doesn't complete at all, that every time you process an event, you always go from one consistent state to another, that if one thread is in the middle of updating the database, that other threads don't get, so isolated that other threads don't get intermediate values. An update actually does not block queries, which is also nice. And then durability means that once an update event returns, you are guaranteed that that event will be there even if the server crashes. You pull the plug right after it returns. If you plug it back in, that event has been written and logged to disk, and when you restart your application, that data will still be there. So update and query events are written in the update and query monads, which are actually instances of the monad state and monad reader classes. So forgetting about the fact that the name is different, writing update and query events is pretty much just like writing functions in the state and reader monads. So first let's create a function to insert a new paste. So we'll just give it the paste we want to insert. This is actually going to insert or update. So we're going to use the update monad, which is similar to the state monad. In this particular case, we want to enforce that we're updating the ControlV state, because you could have multiple states, different types of state in the same application. And then we want to get back the paste ID of the paste we just inserted. So this little curly brackets dot curly bracket is part of the record wildcard syntax. What that will do is, if we look at the paste type, we saw that it had 5 fields here. And when we use this syntax here, it's going to bind these symbols automatically for us. So this is basically a shortcut for writing paste ID, title, nickname, format pasted. It's pretty much exactly like writing that, except we don't have to write it all out. It gets expanded for us automatically. So that's a pretty nice feature, especially when you're working with a lot of records. So we said that if the paste ID equals 0, then we want to consider this to be inserting a new paste, and we want to give it a new paste ID. So we'll match on that case first. State. So first we'll get the current ControlV state, and then we'll update the pastes and put in the IX set, where we will insert that new I'm going to type this in and then I'll explain what's going on. So we want to insert the paste into the IX set of pastes, but first we need to update the paste ID because it's currently set to 0, and we need to give it the next unused paste ID. So there's nothing really fancy going on here. It's just normal record syntax and record updates. As you can see, this can get a little bit annoying when you start nesting a bunch of them. So you might want to consider using one of the various lens libraries, like the new one that I think is just called lens, or data-lens, or there's FC labels. There's a bunch of them. This is the exact sort of code that makes people want to have libraries like that in the first place. We're going to skip over those today, just because while they're nice, it's would make the tutorial really long, and it's already probably ridiculously long. So next we want to, okay, so we inserted the new ID, and then we also increment the next paste ID so that for the next time we insert one, we have a fresh number. And then we return the paste ID of the paste we just inserted. If the paste ID was not 0, then what we're going to do is update an existing paste. So do ControlV state. We'll do a get. And then we'll use IX set, and this time we're going to use update IX to update an existing index. So first we get the ID of the paste we're trying to update, and then we give it the paste that we want to update, well, the updated value of the paste, and the old IX set. And then once again we return the paste ID, which we can just extract from the paste. So there we go. That's an update function. Nothing too fancy there. And if you were to, if we were to just change the type signature to state here, it would look exactly like a normal state monad function. The extra functionality provided by update is all sort of mostly behind the scenes there. It doesn't really affect our coding. So I guess the one big difference is if we had done in the state monad, if we had done multiple puts in here, or even if something had happened between the get and the put, if we are using multiple threads, there's a potential race condition with the state monad. We could get it, somebody else could do an update, and then we put it and we overwrite that update. With the update monad, that is guaranteed not to happen. So this will all basically happen inside a transaction, and we don't have to worry about any other threads coming along and stomping all over our data. So next we want the get paste by ID function. This is pretty straightforward. This uses the query monad, which is just like the reader monad. And since we're allowing an arbitrary paste ID to be passed in, it's possible an invalid one could be put in, so we're going to return a maybe. So paste ID. So get one is an IX set function that what's it look like? So so get one has the type, it takes an ix set and returns a maybe value. It returns just the value if there was exactly one value in the ix set, and it returns nothing if there was 0 or more than 1 values. So get one returns let's write out this full line so you can see that in context. So we're going to use ask to get the current ControlV state. We're going to then select the ix set of paste from it, and then we want to get all of the pastes that are equal to PID, the paste ID. Now, because this is supposed to be a unique index, there should be only one, so then we'll call get one on that. And if the paste didn't exist, it would return nothing, and if it did exist, it would return just and the paste. So we need to import get eq as well. Oops, it's capitalized. So get eq, it takes a key and an ix set and returns an ix set. And it's basically a subset of the original ix set that contains all of the values that matched that key. And we have some sort of typo in here. Line 52. Oh, apparently we've made. Okay, so line 52. Oh, here we go. This is one of the. One of the problems with abbreviating control is I keep changing my mind on which way to abbreviate it. Maybe I should have just spelled the whole thing out, but it's too late now. Alright, so this is a query function. As you'll see, it's very compact. We just basically select all the things we want, and it's a little one-liner. Next we need a function that gets all of the recent pastes. We're going to probably, at some point in time when we have lots of pastes, want to do pagination, so let's just plan for that now. We'll set a limit on how many pastes to return at once, and an offset that says how many pastes to skip before we start returning any. So then we can do get recent pastes. I'll give it the limit. Let me put a comment here. I'm mostly skipping over comments because you don't really want to watch me type these all, but maximum number of recent pastes to return. Offset. Let's see, number of pastes to skip. Let's make these line up all pretty. And this is a query function as well, so we're going to use the query monad. ControlV state. And this we'll have this actually return a list that's already sorted for us in reverse chronological order. So get recent pastes limit offset equals. We could try to cram this all into one line, but it doesn't hurt to make things a little bit more readable and put them on 2. So we'll use ask, and let's start taking some stuff out of here. So we have an ix set. We want to sort it by reverse chronological order. To specify what key to sort by, they're all done by types, but we don't really want to pass in a value, so we just use proxy. So proxy, this actually is now defined in a library, and we should be using that version, but we're not yet. Data.proxy basically has a phantom parameter here. There's only one constructor, and we basically just use this to provide type signatures to the compiler so that it can do its type checking madness. So this here will take the ix set and turn it into a list that is sorted in descending order by the time field. And now we can add in our functions to do the limit and the offset. So first we want to drop whatever the proper number of beginning entries are, and then we want to take whatever our limit is, and then we don't want to return all of the pastes because we're just going to use this to create a list of recent pastes, and then we're going to link to the actual paste. So we really only need the metadata here. So we can just do map paste meta, and then we gotta lift that all up into the monad. Bam. So now we have all of our acid state query and update functions. We need to register them with acid state and say, make these functions be acid state methods or acid state events. So this is also a little bit of template Haskell code. Once again, like really boring. You would never want to write these instances by hand. If you look in the acid state code, you can see exactly what they do, and then you'll be convinced that you definitely don't want to be writing these by hand because it's really, really boring and nothing interesting is going on there. So the one interesting thing that this will do is it will create new constructors that have the same names as these functions, and they take the same arguments. So looks like we're going to need some more type families. So if we look, we have get paste by ID the function, and then we also now have get paste by ID the data type. And so it has the same name, and like the function, it takes a single argument, which is a paste ID. So we'll see how to use these in a little bit, but that's sort of the magic of make acidic, is it creates those data types, and then it also creates a number of instances for those data types that will allow us to do the updates we want to do. Next, let's define the routes for our application. So this is where we use web routes to create a type-safe URL. Type-safe URLs, it's a pretty straightforward concept. Instead of putting strings in all of our code for the URLs, we instead create a data type to represent all of the possible routes, and then we use that data type everywhere in our code. And then we have one little piece of code that actually converts between that data type and the string representation that you're going to see in the HTML or in the browser. And there's a number of reasons why you might want to do that. One, it helps catch simple typos. If you mistype the name of a constructor, you will get a compile time error, whereas if you were to mistype a string, you would just get a bad length that you may or may not notice. It's really useful when you have routes that change. If you decide to add an additional argument to a route, or remove an argument, or remove a route altogether, because it's type checked by the compiler, you'll actually get a compile time error if you have not updated all of the code properly. And that's really useful when you are importing third-party libraries and using the routes that they provide, because especially given the fact that Hackers does not do changelog tracking, it can be really difficult to know that a third-party library has actually changed the routes and basically changed their API. So by using static web routes, you actually do get compile time errors. If the third-party library changes the URL type, you will get errors. And then it also is actually really useful if you're using plugins, and like if you're using plugins or subsites or anything like that, it's a good way to ensure that each of those separate components has its own unique namespace, so that you don't have two different components that are both trying to handle /submit. Web routes will actually provide them with unique URLs so that they don't collide. So we need to be able to view the most recent routes. We need to be able to view not the most recent routes, the most recent posts. We want to be able to view a paste by its paste ID. We need to be able to create a new paste, and we're going to want to probably apply some style sheets to this site, so we'll create a route for the style sheet itself. And so once again, we'll drive a bunch of things. We don't really need all of these, but it's nice to provide them in case somebody does. And then we're going to call derive path info on this route. So there's a lot of, with web routes, there's a lot of different ways that you can define the mapping between the route type and the way it looks in the browser. The easiest way to do it is to use this template Haskell code, which will derive functions to do that automatically using a very simple rule. Basically, view recent will get turned into view recent. View paste will get turned into view paste slash the paste ID, and so on. So new paste will become new paste, etc. So very simple rule, and because the route type is basically, we can use whatever we want. You can sort of pick route names that are going to generate the type of URLs that you want. If that doesn't give you enough control, there's also options to use boomerang or quasi-quoting or a bunch of other things to define what your route looks like. Most of the time I just stick with derive path info because it's good enough, but there is, like I said, there's possibilities to do it other ways. We won't go into those today because it would make this even longer. So let's see. So the next thing we're going to want to do is we're actually going to start getting into writing some of the server level code. The foundation library provides a bunch of type aliases which sort of integrate all of that functionality together. So it provides a type such as this one, which is formatted really horribly here, but if we change the formatting here, we can see that the foundation type is parameterized over 4 different values. The URL here is our route type. The ACID state is the value we want to store in ACID state. Well, it's the type of the value we want to store in the ACID state. The request state parameter here is an optional value that we want to store inside this state monad here, that it's done on a per request basis. So if you have, I don't know, some per request state you want to deal with, you can stick it in there. We're not actually going to use that in this application. And then M is the monad that we want to transform. In this case, so we don't want to have to type that in every time. So let's fill out some of this parameterization. So we'll do foundation T. Our URL type is route. Our ACID state type is ControlV state. We're not going to use the request state, so we'll just set it to unit. And we're not going to transform over anything fancy. We're just going to be based on the IO monad. And then we have to create a second alias here with the XMLGenT transformer. The XMLGenT transformer is related to HSP and generating HTML, and I would love to get rid of it. It actually doesn't do anything of interest except make the type checker happy, but it makes me very unhappy. But it turns out it won't affect our code too much. It's just another one of those little annoyances that keeps pecking away at me. So we're also going to define an alias. There's another type called foundation form, which parameterizes the form type, which comes from reform. This is the type that we're going to use for generating our type-safe forms. Once again, we're just going to create a type alias to to get rid of all of those type parameters because there's too many of them, and we only need one set of values for this whole application. So a type alias is a good way to go. So do foundation form route ControlV state IO. And foundation form. So once again, we can see it's parameterized or the same things as the other things were the URL, the access state, the request state, and the monad. So that's why you can just plug in the same values there. And let's get rid of this. Spelled ORD wrong. All right, so now let's actually define a little page template that's going to show, that we'll use to wrap around all of the HTML pages in our application. So let's call this app template. And the app template is going to take a string that we can use for the title, a list of extra headers to add to the head tag. Well, actually, it's not a list, it's something that we can stick in the header, basically. Something that we can stick in the body. And we'll have this return a response. So response here comes from Happstack server, and it's just an HTTP response. It's got the response code in the body and all that stuff. Now we need to also specify some type class instances here. ControlV headers, embed, body. So these embed as child instances come from HSP, and they basically, what they're saying is that, sorry, fixing the formatting. So basically what they're saying is that we require that the headers, whatever you pass in for the headers and whatever you pass in for the body, be an instance of embed as child, and embed as child is what allows you to make something the child of an XML node. So title, more, headers, body. Let's do body so that we don't have. Okay, so we want to create a template. We're going to mostly just call through default template, which comes from HSP, and it provides a template that's already got like the HTML tag and the head tag and the body tag and things like that. We're just going to add a little bit of extra stuff in there, like our page menu and page title and logo and stuff like that. So it takes the same arguments as app template does, the default template. We want to add some additional headers, namely a link to our style sheet. So we're going to put this in. So we're going to say link rel equals style sheet href equals css, type equals text / css, media equals screen, more headers. So let's change the indentation here so it's not going off the screen. So here's our first encounter with the literal XML syntax that HSP provides. You'll remember that way back at the beginning, we had this funny options GHC line that said run trhsx over the code. And what trhsx is going to do is it's going to take this code, this markup here, and turn it into plain old Haskell code that GHC can understand. So we can actually run this. Oops, I guess it got mad because I have a type error here, so let's just add an undefined in there for now. And we need flexible context. And and we I haven't passed in the body argument to default template yet either. So let's put that in as well, and then I'll explain what's going on here. So for our body, we're going to have a logo. We'll give it an ID so we can style it, and we'll call it control. Oops. I don't want to actually press that. It's hard to say ControlV and not type ControlV. Alright, so ControlV. Or if you're an Emacs user, you might want to call it ControlY. Once again, I can't type it say it without typing it ControlY. And then we're going to want to put in a menu. We'll give this a class. I'm never exactly clear on when I should use an ID versus a class, but it doesn't seem to hurt to use a class here, so we will. And we're just going to hard code in our menu. So we need, see, the first item in our menu will be, how about add a new paste? New paste. And the second menu item will be view recent. So let's say recent pastes. And then after the menu, we need to stick in the rest of the body that was passed into this function. Alright, so now that this type checks, we can run it through trhsx, and we'll see that for the most part we have the code we wrote. It's got a bunch of extra pragmas in here which just tell the compiler what the original line in the source code was for error messages. We can ignore those. So if we look here, we have our app template, and you'll see that the literal XML code we wrote here, hold on, this computer is chunking along here. I'm going to try to stop the backup and see if that fixes it. Also, hopefully I'm not running out of disk space. So see, the call to default template title and then all this crazy markup here was basically just translated into a bunch of very simple, straightforward Haskell function calls. So this thing said make something a child. Here the link tag got converted into just a function call to gen element with a namespace of nothing because it's HTML and link, and then all of the attributes got transformed into as attribute calls and more as child calls. So it's a very simple transformation. The code that the HTML that we're writing here is neither normal HTML nor is it exactly XHTML, which can be actually not confusing. It turns out that if you use the normal XML syntax of closing all your tags or using short tags, and you forget about the fact that normally you have to escape things like and. Basically, if you type XHTML the way you sort of intuitively would like to, forgetting about all those weird escaping rules and stuff, then that's what we get here. So what we're doing is we're creating an XML document, and then later that will actually be transformed into plain old HTML, sort of automatically behind the scenes for us. So the other interesting things we see here is, okay, so for the most part we're using normal XML syntax. We'll see we have this special escape mechanism here. This allows us to embed Haskell expressions inside of the literal XML. So what happens is this Haskell expression will be evaluated, and as we saw in the transformation, it'll actually call as child to try to turn whatever that value is into some XML, which will then be inserted into the XML tree. So this is how we embed Haskell values inside here. Right here, we're just using I mean, we're doing very straightforward value substitution, but you can actually put any arbitrary expression here. So if you wanted to do a conditional thing, you could say if true, then more headers, else more headers. It's sort of pointless, but you can put whatever Haskell expression you want here. We could put maps, you could put folds, you can put pretty much anything in there. These expressions are going to be run inside the ControlV monad. So you can even do monadic stuff like map some function over some list. I think we'll actually see an example of that later, so I won't talk too much more about that now. You'll notice that for the href here, we just put in CSS, which was the constructor we used that we created up in our route type. And same for these hrefs. So here's the integration of the web routes type safe URLs in HSP. We don't have to do any funny escaping or anything. We just stick the values right in there. That works in part because the arguments to these attributes are always just normal Haskell expressions. That's one of the reasons why actually we have to use double quotes here for style sheet. We can't use single quotes because that's not a valid Haskell. I mean, that's how Haskell represents characters, and that's not a valid character because we want to put a string in there. We actually have to use the string syntax. But you can put an integer or whatever, and it will use the embed as attribute instance to convert that into an attribute. So once again, we could put arbitrary like if, foo, then, and things like that there. But once again, it's all pretty simple here. And then this syntax is basically just a way, so in XML and in HTML, you can't just have a list of elements, they have to be inside something. So we could write div tags here just to put those elements inside something, but we don't really want div tags there. So this is just a way of saying that we're generating a list of elements and somebody's eventually going to have to wrap something around the outside of them. But if you don't like that, you can just put in dummy div tags and stuff. So anyways, now we've created the HTML. So now we want to actually turn that HTML into a response. This is where so to do that, we can just use the toResponse function, which comes from the toMessage class, and there's an instance for XML that will do the right thing for us. And OK is how we set the HTTP response code. OK is kind of, well, it does two things. It's a kind of like the return function. You'll see it has a very similar type, except in addition to doing what return does, which is lifting the value into the monad, it also adds a filter that will set the HTTP response code to OK. So there's a bunch of these. There's not found, bad request. All of your request codes have little helper functions like that. We could also, if we wanted, because it's installing a filter, we could actually write it like this and make it look more monadic-like if you don't like composing things together. In this case, that's not a big win for us, but sometimes it's easier to read when you do it that way. So we're going to leave it like this for now. So the other thing we're going to want to do is create a few embed as child instances for values that we're going to want to embed into the HTML. So we're going to probably want to stick a bunch of paste IDs into our code, so we'll create an embed as child instance for that. So we're going to say paste ID, and we're going to make this a child. And so basically we're going to get the integer out of the paste ID, we're going to show it, we're going to put a hash, a number sign in front of it, and then we call asChild again to convert this string into XML. I think in this case we could use C data instead or something like that, but I can never remember if I want C data or PC data. So asChild will do that all correctly for us. And we're going to want to embed those times into the HTML as well. So we'll create an instance for that, asChild time. We'll just call show here. The show instance for UTC time gives all of the precision it possibly can, so it's going to give us like microseconds and beyond. So really you probably want to use like format time here, but it's kind of beyond the scope of what we need to do for this, so we'll just use show for now. Now let's actually generate some pages. So we're going to have 3 pages: the most recent page, the page for viewing a single post, and the form for adding a post. So view recent page. I'll just use our little monad here. View recent page. So if we want, we can make it so that this page is only good for GET requests. Honestly, I a lot of time leave these out because I've never gotten burned by not leaving them out. But in theory, we should put in method GET here so that this will not be shown if somebody does one of those other request methods like a put or a delete or a post or something like that. Then it will return a 404 instead of returning a HTML page. So now we want to get the responses, so we'll do get recent pastes. We'll get the 20 most recent pastes and we won't skip any. This obviously isn't going to work once we get beyond 20 pastes because then there's no way to get to the second page, but that's really just, there's nothing exciting there, so we're just going to do the easy thing for now. If there aren't any pastes yet, we'll do app template recent paste, so there's our page title. We don't really have any extra headers we want to add in, so we'll just give it unit, and it'll say there are no pastes yet. If there are pastes, then we'll call the app template so here's a case where we can do the OK like this, and then do app template. In fact, now that I think about it, we should not have that OK in there because we want to use this even when things are not OK. So we're going to change that to a return. So by default, OK is actually implied, so we don't have to put it in there, but it's kind of nice too. So we'll say everything's, if we got this far, everything's OK. And I'll do recent pastes, no extra headers. And now we want to make a table that contains links to all the most recent pastes. So let's do recent pastes h1. We'll give it a title. We'll make a table. We'll put a header on our table. And we'll have only one row for our header, but it'll have a number of headers in it. So looking at our paste type, we want to have an ID field. We want to have a title. We want to have an author. We want to have a date, and we'll show the format last. And so that's going to be it for our head. It's got one row, T head, T body. So now we want to make all of the rows for the table. So we're going to use the map function. We'll do make table row over recent, and table. And we'll close this off, and we'll put in a where, and we'll make our make table row function. So it's going to take a single paste, and we'll use that record wildcard syntax again. And so we'll make a table row, table data. We want to make some things link to the post, so we'll make the ID link to the post. We'll do view paste, paste ID, and I think we made paste ID and embed as instance, we can just do BAM. And we'll also make the title be a link. So do view paste ID. So here we want to use title. I think that's all we'll have link. So the next was the authors, the nickname. So nickname. And we also want the format. We'll just do show format. It's going to be a little bit ugly. We should probably pretty print it or something, but we can fix that later. Let's see if this compiles. No, it does not. A mistyped response. This is why I use a type checked language. Response. We need type synonym instances. We need flexible instances. And once again, I want you to stopping back. It's still stopping, I guess. All right. We need a lot of extensions here. Multi-parameter type classes. Multi-param type classes. Good, compiles. So the only really new thing we saw here was the use of the query function. I guess I kind of skipped over this. The query here is how we actually get something out of ACID state. We call it query, and then we give it the name of the method and its arguments that we want to use. So you'll remember we had get recent pastes, and so you'll see that you pass in a limit and an offset. So that's exactly what we do here. It won't work to do get recent pastes 20.0. We actually have to call the query and the type class. This is basically how ACID state gets involved in the system to ensure that all of the acidness happens. The rest of this is just more HSP code. We see here we're just using, in order to iterate over the list of recent paste, we just use map. This is one of the things I really like about HSP is that it doesn't have its own little sub-templating language where you have to learn some new language. Instead, it just uses Haskell, and you get all the power of Haskell and all of the things you already know about Haskell in your template system. Obviously, this can be abused. You will notice that we did the query up here, and then we passed that value into the template, used it down here. We could have actually done the query right here. We could have done something like, I can type. Where did my equals go? I'm so lost. There we go. We could have done something like this. Get recent pastes 20.0. But there we are really starting to mix the business logic and the template, the view, and the model, and the controller all together. So it's kind of probably a better idea to do it like this, where we keep things a bit separated. If you wanted to be really dogmatic, you might actually have recent page only do the query and put all of this app template stuff in separate functions, like view recent page HTML, and you would actually pass that recent argument into the view explicitly. Usually I don't do that unless I think there's actually code I'm going to reuse in multiple places. I'm not quite sure what the advantage of dividing things up that fine grain would be. So here's an example where we will actually split something out. Let's do the new So we're going to do the new paste page next, but one of the things it's going to have to do is format a paste. That sounds like something that might be reusable, so we want to know the format it should be, the raw text of the paste, and then we want to return the XML that's associated with that paste. Format paste goes plain text. So because we're just doing plain text, this is actually really simple. We just use the pre tag and we stick our text in there. Now HSP does automatic string escaping for us, so we don't have to worry about any sort of JavaScript injection tags or anything funny like that going on here. We just put that there and it's automatically escaped and we don't have to worry about it, which is really great. Obviously, if we had something besides plain text like Markdown or whatnot, then we could do all that processing in here. So now we can make the new paste page. So this is going to have a form on it. Like that's what the page is. It's a page with a form, and we want to collect the paste information from them and validate the form, and if not, we show them the form with the data filled in and some fields showing what they missed. Otherwise, we add the new data to the database. So one of the first things we're going to know is where we are, so that when we create the form, we can actually create a link to it. So we can use this where am I function, and it will give us the route type that says where we are. So that way we can get here again. And we'll do add template, add a paste. Once again, no extra headers. We'll give this page a title, add a paste. And next we want to put the form. That's going to be really the only thing on the page. So we want our form to link to here. We have to give our form a unique name. This is also something I would like. I really don't like the fact that you have to do that. It would be nice if it could automatically generate unique names, but it's been a little bit tricky to get that to work reliably, and I've never actually run into a problem doing it this way, so we're going to do it that way for now. So if the form validates successfully, then we're going to take the form validation value and pass it to success to do whatever a successful form should do. If not, then we need to call the error handling function. We're actually just going to pass in nothing, which means that it's just going to redisplay the same page in the same context, but with the error values passed in. If you want to do something different, then you can do just and give it a different error handling function, but nothing works really well most of the time. And then we give it the name of our form. We haven't actually written it yet, but we're going to call it paste form, and it's going to be a little form that collects all the form values. So we'll close that off, and then we can put in our success handler right here. So the success handler is going to get a paste that it got from the reform stuff, and we're just going to call our update function. So we'll do update, I believe it's called insert paste, and there's no case where insert paste can fail, so we're always going to get back a paste ID. And then, so after we've added that paste, we want to look at it, so we'll just do a 303 redirect to view paste PID. So next we need to actually make our paste form. So it's going to have type ControlV form, and this form is going to return a paste. So there's a lot of ways to create and format forms. I've been using a method where you wrap it all inside a list, and I also like to put field sets around the list just to have them there. We'll probably style it out eventually anyways, so we'll do field set, we'll do an unsorted list, we'll do a list element. So next we need to collect 3 values from the user. We need to collect the title of the post, the title of the paste, the author name, and the actually we need to collect 4 values. the title, their name, the format of the paste, and then the actual content of the paste itself. So reform, most of the time you're going to be using the normal applicative instance. So we'll make a little tuple to hold the values, and we'll start to spell them out. So we're going to have a list element. The first thing you want to have is the title. So we'll add a label tag and give it title span input text. So here we have a title tag, and so label comes from reform. Actually, all these functions come from reform. Field set, ul, list I all come from the reform library, as does the label function. This label function is going to generate a label tag, and it's going to automatically set the for attribute of the label tag to be the same as this input element. So here we're using input text, which is equivalent to input type text. And we want to say that the initial value is just going to be an empty string. There's not going to be initial default value. This operator here comes from reform. It's similar to the normal applicative function that looks like this. The difference is if we wrote this, then the label tag and the input text would have different ID fields, which means that label wouldn't know how to assign its for attribute to be attached to the input text. When we use this, they actually share that same unique ID, so the label now knows how to refer to this guy here. So we can do this, so we can do a label. I think we say we want to do author next, or we can do Nick. Input text, and then label span format. For this, we're going to want a drop-down box. It's going to be a little bit awkward to try to put it right in line there, so we'll just make a little where clause that's got the format form. And then finally, I'm going to label for the paste content, which we will call paste. And we want this to be a text area, and we'll make it 80 columns by 25 rows. So now we want to transform this whole thing. First we're going to put in our format form. So for format form, we want to use a select widget, a drop-down box, which is called select. So if we look at the select type, it doesn't render it pretty. If we see look at the select type, we see it takes a list of pairs. The first attribute is the value, and the second attribute is the label as should be shown in the browser. It takes a function that tells you if a value should be initially selected or not. In this case, it has to match exactly one value, and then this form returns that whatever value was selected. The select box is required to always return a value, so that's why this returns A as opposed to maybe A. It's a little bit annoying that we have this requirement that this has to match exactly one attribute, but there's no way to enforce it. We could use some really crazy types to work around that requirement and ensure that always exactly one of these was selected, but the types to do that just got too messy, and it didn't seem worth it. The overhead of having to think about what all the types meant made it too hard to read compared to the gain of actually ensuring exactly when element was selected. Although if we could find a clean way to do that, that would be lovely. So let's say format Once again, we'll just do show to show the format. And then we need a list of all the supported formats. We only have one now, which is plain text. If we had left in the bounded instance, we could actually do like, well, the bounded and enum instances for format. I think we took those out, right? Format. So we left out the bounded and enummed instances for that, so we actually have to list these by hand. If we had left them in, we could do like min bound to max bound, but we'll just do this by hand now. And then we need to say which one is selected initially, so we'll just use the little equals operator. And that's all we need for that. So one problem here is right here we're collecting a tuple of 4 values, but we're supposed to return a paste. So we need to actually transform those values into a paste. So we're going to use transform either, and we're going to give it toPaste. So then we'll write a toPaste function, and it's going to take the title and the nick and the format and the paste. Let's give these all different titles. Title, nick, format, paste, and we're just going to stick them all in a big old record. So to transform either is used to convert values. In this case, we're going to go from a tuple to a paste. It returns an either value because sometimes that may fail. For example, if you're trying to turn a string into an integer, not all strings can be converted to integers, so it might fail, in which case you would return left and an error. In this case, it's never going to fail, so we're going to return right. Well, first we need to know what time it is. So do now get current time, and then we can do return right paste paste meta equals paste meta equals paste ID equals paste ID 0. So we don't know what the paste ID is going to be until we stick it in the database, so we use our special value of paste 0 in the meantime, so that to fill in that hole, the title is going to be title, the nickname is going to be nick, the format is going to be format, and pasted equals now. So that's the metadata, and then the paste itself is just going to be paste. Ooh, got a nice big error here. So this is one of the downsides of HSP, is when you do something stupid, you can sometimes get these type errors that are ridiculously long. One of the things that we are working on is one of the Google Summer of Code projects is a type checker that can be used with HSP, and that will allow us to give much nicer type errors. So here, I think it's mostly complaining because it doesn't know what error type it should use, because we haven't done any error validation in here yet. So let's add some, let me look and see if that's the most, oh, no, I think this is the problem is, well, that was one of the problems. We did not give text area a default value. That's another issue. And when we got the current time, we didn't use lift.io to put it in the right monad. And let's see. Let's start at the top, see what we got left here still. Okay, I use transform either, but that's only if you're doing a pure transformation. Because we needed to get the current time, we need transform either m, which is the monadic version. Okay, so we cleaned up those type errors. Like I said, they look really scary, and in fact it does take a little bit of time to recognize the patterns, but once you recognize the patterns of what the errors look like anything else, it becomes easy to read, or easier to read. But definitely improving the type errors generated when using HSP is a high priority. So now we have our form, everything compiles. So now we need to make our route mapping function. So we'll do route ControlV. It's going to return a response. So the route function takes a URL, and then it basically maps that URL to the functions that are going to handle it. So we'll do case URL of view recent. It's going to be view recent page, view paste, PID, view paste, page PID, new paste. Should go to the new paste page, and CSS should serve our non-existent CSS file. Let's put that in now. So we'll do serve file, which serves a single file off the disk. We get to say both the content type of the file and where that file is located. So this is going to be a text CSS file, and it's just going to be located in the same directory as style.css. So you'll notice that this function is pretty boilerplate looking. In fact, if we change this to CSS page, it would be pretty much entirely boilerplate. One of the things that we have in web routes, but I think it has not been released yet, is a function where you could just do where you could do make route bam, and it would automatically generate this function. The route function is not always that formulaic, but when it is, it's nice to have a little function that generates it for you. And then lastly, we have our main. So main, like always, is the IO type. We're not going to parse any command line arguments or anything. We're going to call simple app. So simple app has a type that looks a bit like this. It takes quite a number of arguments, but they're all pretty straightforward. The first argument, which is perhaps the craziest looking, is simply a function that flattens the inner monad. If you remember, in our ControlV type, the inner monad is IO. So we need a function that goes from IOR to IOR, which of course is just the ID function. There's nothing to flatten there. Conf is the normal happstack configuration type, so we'll put in null conf. By default, that just says listen on port 8000. Next, we need a configuration for asset state. So we want to use a local asset state database. We'll use the default path to store that, and the initial value is going to be the initial ControlV state that we passed it. The next argument is the request state. We don't use that, so we just set it equal to unit. The URL here is the URL that we want to go to when the user goes to slash. We get to pick where slash is mapped to, and in this case we want slash to be mapped to viewing the most recent posts. And then the final argument here is our route function that's going to take the parsed URL and actually map it to a page handler and return a response. So that was the route function we just defined here. So, as content type. And apparently it was not called view paste page, it was called What was it called? Oh. Apparently I never actually wrote the view paste page function. I skipped right onto new paste page. So let's go back to view paste page. View paste page. It's going to take a paste ID, return a response. We'll say that should only respond to GET requests. We will try to get the paste. Get, oops, not get, query, get paste by ID PID, case m paste of. So if the paste is not found, then we want to say it's not found. That's a 404 page. And we'll say app template, paste not found. And I'll say paste PID could not be found. If it is found, then paste. Use the record wildcard syntax here again to get all the metadata nicely matched for us. And we'll do, this is going to be okay, so we'll do okay app template paste. Now we can't use our embedded child instance here because this is just a string, so we'll just do show unpaste ID PID, no extra headers. I'll do div class equals paste. I'll do it lowercase. Who does uppercase in CSS? All right. I'm going to use a definition list because this is kind of a definition. We have key value pairs, and according to the W3C, that's a perfectly valid use of definition lists. So, so our definition list. So we're gonna make the header for the paste, the stuff that contains the metadata, and then we'll actually make the body. So it's the header stuff that's going to be the definition list. So we'll put in the terms, paste, dd href. We'll make it link to itself because why not? PID. Oops. We'll show the title, and this is just going to be title, and author, actually it's nickname if I'm not mistaken, nickname, and I think we want to say when it was pasted. Let's put that in too. So DT pasted Doop. All right, so there's our header stuff, and then we'll do paste body, and we'll just so here's where we call the format paste function. So you say format paste. We can even put a format tag in here. Why not? So let's say format show format. Close off this div tag. Parser in I think think we have one too many parentheses here. And no instance of typable ControlV state. How could that be? Because I never added it. So deriving some of these equord, read, show, data, typable. And here we got a nice compiler warning because I didn't capitalize that. Alright, so now this compiles. So let's do main. Go to Google Chrome, load it here. So now we have our site. We can go see the new paste form. We can see the recent paste form. There are no pastes, so we can't see a specific one. The site's pretty ugly, so let's start putting in a little bit of a style sheet. Let's see. Let's just put in something simple to start with to make sure that the style sheet's being read. Let's make the default font size 16 pixels. So it'll make it easier to do grid stuff since it's a multiple of 8. New font family sans serif. I'll make the width about 45 EM because it's going to make things more readable. You don't want it to be scrolling off the page. We see it's sans serif, so we know this is working. Give it a little bit of a margin on the left of 2 EM. Alright. Let's work on our logo and menu maybe. So we got a logo here. We do make it bigger. Font size equals 3 EM. Let's actually do our menu, which is the class. We want to do display inline block. Let's make this display inline block. So they'll go next to each other. And then you display, actually, I think this is attached here, so we can get rid of this. We don't want any list markers, so we'll do list style type none. And then we want our list elements to be all in a line. So we'll do display inline block. Okay, looking a little better. We want we're gonna kind of go for like a Apple web pagey type logo. So we're going to make these. Let's add a background somewhere. I think here, let's add a background. We'll just make it like a gray color for now. So we'll do, this is probably too light. Do 888. Great. Let's make our things padding 1 EM. Bam. Color, I'll make the text white. We'll remove the text decoration. Decoration none. I don't want the underlines. These are not fat enough. So we need a display inline block probably on this. Display inline block. Bam. So now I got them fat. Now I want to give them some nice rounded corners. So give our menu rounded corners. Give it border radius 5px. Fancy. Now I think we want some separators between them, so we'll do border right 3px solid white. I'm thinking we got some margins or something I think we want to kill. Just kill all the padding and margin here. There we go. Not sure what happened to our right border radius there. It's because we got the border right. I love CSS. What happens if we add a border radius here? Well, it's a little funky on the right here, but this is not a CSS tutorial. It's still weird. Whatever, good enough. We're not going for perfect here. Let's put a little text shadow on this. Text shadow 1px, 1px. All right, let's make so these things are not lined up so well, so let's do menu vertical align middle and vertical align middle, and let's give our logo some padding on the right, our margin rather, margin right. I'll make it 16 pixels. Keep everything on the grid. All right. So there's no paste yet. So now new paste. Now we got a bunch of our forms looking pretty ugly here, but we can clean that up with some CSS. I think the first thing we'll do is let's do form theme. First thing we should do is kill the margin. The whole field set margin, padding, border, none. So we don't actually want to see that field set in this particular thing. For the list that's inside that field set, let's also kill all of its default margins and padding, and get rid of the list markers, so list style type none. And then our label tags are all jaggedy here, so let's say that let's make our labels the ones that are the span tags, let's give those a minimum width. Let's give this a minimum width of let's just do it in pixels, 64 pixels. That didn't work for some reason. Oh, it's because these are inline elements. We need inline block if we want them to actually pay attention to that. So now we have everything nice and lined up there. Let's make all of our labels bold. Font, weight, bold, bump. And oh look, in our form we forgot to put a submit button. I do that every single time. So let's go look at our form again. It's called paste form. And we will add in a input submit paste, and just put that inside the field set to keep things clean. So boom. So now we get our title. We got all sorts of good stuff. So now we can. So other things we could do, we could change our form so that this title field was bigger and things like that. But just put in our first paste step cut. This is so awesome. So now we can do paste. And now we actually see a paste. So once again, this looks pretty horrible. So let's see, paste theme. So first we want to start by theming the paste header. There's a definition list. And I think we want to make it all monospace, so we'll do font family monospace. Looks good. And then I think we'll just do a border at the top and the bottom. So border top 1px. Make it 1px solid black. Bottom one's sunk. And then we kind of want these things on a line, not written out like normal definitions. Let's just do paste header float left, clear left, and let's make it bold too. Font weight bold. Boom. All right. It's looking better there, but now everything's too crammed over, so we want some padding. Since we floated things, we can use the margin left trick. So we'll say margin left 8 EM. And now we got some spacing there. Let's also add a little line height here. Line height 2. Sure. So this is so awesome. Alright, that's looking good. So now we can go to recent pastes and we see that our table here is a mess. So let's do recent paste theme. So I don't remember if we assigned a table. We didn't really assign a CSS class to that table, but we'll just make the default tables in this app all look the same. So first thing I want to do is make my headers bold, font weight bold. I'm going to make them let's do a border bottom 2px solid. Pick something bluish. That looks kind of nice. Let's make it a solid line, so we'll remove the border spacing. Boop. Things are kind of crammed there, so let's make the line height 2. Zoom. Our cells are all kind of crowded together, so let's try giving them some padding on the right. Got like 3 EM. That's looking better. Those links are a little bit ugly. Let's just do all of our links to be the same style. So do text decoration none, but we'll give them a nice color. We'll give them like 1.8C. How's that? That's not bad. and then we'll add a hover tag. Text decoration underline, so that way they respond in a somewhat familiar way when you hover over them. So now we can click here, recent paste. It looks like we missed a field here because plain text is under date. So let's go fix that. So nickname, let's put it in pasted. And there we see an example of this ridiculously long date. Now, I don't like these titles being centered. It looks kind of erratic to me, so let's do text align left. Bam. So there we go. And if we don't like this color, because it's kind of boring, we can do like inspect element. And no, not what we wanted to do. Take me out of here. So you can do inspect element and make sure you get the right one. List element. Okay, so this gray background is kind of ugly, so it's kind of hard because the screen's so small, but we can. No. Ooh, I come back here. Oh, I put it inside there. How convenient. Okay, so. Ooh, it's still not convenient. Okay, so now we can actually go in here and change the color of this header till we find something that we like. So we could spend a long time moving this around looking for a good color. So instead we'll just pick this one. So we can then copy it and background in our menu, I'll set it to that and get rid of this, and now it's stuck. So there we go. We sort of skipped over a lot of stuff. Let's do a quick review of the code, because it kind of took us a long time to get here, even though it's supposed to be easy. But if we look, we see it wasn't actually that much code, just a lot of talking. So for our model, we created a simple paste ID, which is a new type around an integer. We have a format. We have a simple record type that defines our metadata. We get to use all of our normal Haskell data types here. We even get like algebraic data types. The only really restriction for our types here is that we need to be able to create a safe copy instance, which is basically kind of like a show and read instance, but binary and combined into one. And so basically, if you could create a show and read instance for a type, you could stick it in your ACID state database. That basically doesn't eliminate much. You can't put functions in your database. You cannot put existential types in your database, and there's probably something else, but those are about it. So almost anything can be stuck in an ACID state database. We created some indexes for our paste type so that we can easily get it from a IX set. We created a type to hold all of our state, so we can think of this maybe like a table, or maybe your whole list of tables in a normal database. It's not really supposed to be a one-to-one mapping, but similar idea. This is our entire database. Our initial state, once again, just a very simple record. We wrote our update and query functions, which were just very straightforward functions similar to read and state monad functions. If we wanted to make some of this stuff cleaner, like we said, we could use the lens, one of the various lens libraries, and that would make these things a little bit less verbose. But we didn't want to get into lenses today. We defined a route type, a type safe route, which gives us all sorts of nice type safety issues. Solves all sorts of type related issues. We we defined some simple type aliases to parameterize the foundation classes. We made a little template for our website. We could have just stuck with default template, but we wanted to have a logo and wanted to have menus and other things like that. So we just created a little wrapper around default template. Just for our own convenience, we created some embedded child instances. And then we wrote some simple page handling functions, which mostly just generate more HTML and stick things in them. Here we queried the database, a simple small one-liner. We didn't have to do any sort of marshalling of the data or anything fun there. We just got a Haskell value out of the database and used it, which is really lovely. Here was an example format paste of sort of defining HSP macros. It's kind of overkill to call them macros because they're nothing special. They're just Haskell functions. That's one of the really great things about HSP, is that it is just Haskell. So we don't have to define all sorts of new things. We just use the old familiar things that we already know and love. And of course, we get type safety and all that other stuff in our macros. We know, for example, that this value, we can't call format paste without passing in text. We're never going to get a runtime error where this is missing because it's the type checker ensures that format paste always gets a text. View paste page, nothing really exciting there. The new paste page we saw where we used reform to create a form. In this case, we didn't do any validation, but we could modify it so that it did. If we wanted to make a field required, we could do that. In fact, let's take a look at that because it's not too difficult. So let's say that we want to make the title be required. We could then do transform either, so we'll use the pure one and we'll say it's required, and then if we'll use this to attach a list of errors if they fail to put that in. So then we'll say required, and let's use these. If text.null text, then left required. Otherwise equals right text. And let's kill that. So let's make all the fields required. So transform either required, and we want to, if there's a, so with this error list, what we're doing is we're saying where we want to attach the errors for this element. So for these, we want to put it after the field. For the text area, we want to make that required as well. Transform either required, but we actually put the error message before it because it's a text area. It would be weird if it was at the bottom. So we sort of want to stick the error message in between the label and the text area. So we'll do error list. I don't think we need that parenthesis. Bam. So now if we go to this page and we say new paste and we do paste, it will tell us that all these fields are required. And we could of course style those up nicely as well. Error styling. We won't do that right now because it's boring to watch me do CSS. But I'll do that later. So next we had our route function, which is incredibly trivial. And then we had our main function. So we clocked in at 280 lines here, which is not bad at all. And if you look over this, you see that there's not really a lot of boilerplate or extra code in here. Pretty much all of the code that we see in here is stuff that is specific to the logic of our application. It'd be really difficult for us to pull much stuff out of here and make it more general. If we were going to do that, the place that it would possibly be would be these AcidStateEvent functions. Obviously, this pattern of inserting a paste into a database, getting a paste from the database, and getting recent ones, you could imagine these types of patterns coming up fairly often in a lot of applications. For example, if we were to write a blog, we might have insert blog and get blog by ID. And so this is actually an area where we could try to provide some template Haskell functions that would generate some acid event stuff for us. So we could do the whole CRUD thing or whatever. That's quite possible. I know some people have experimented with it, but we haven't released anything official for doing that yet. But that would be the most obvious place to try to kill some boilerplate, is in these very generic type queries. Now, obviously, a lot of applications might have fancier queries that do a lot more logic and go beyond just sticking a record in and getting them out. So this is not really the best example of the full power of acid state in terms of being able to do really advanced queries and updates. But it's already a really long presentation, so I'm glad we kept it simple. That's all for now. This whole application is available actually in the source code for Happstack Foundation. So if you get that, you can see this example. The style sheet will all be finished off. And in this demo, I put everything in a single file. And for the example, I will probably also leave it all in a single file because it's a pretty small application. It makes it easy to find. But if you were building a full-size application, you definitely don't want to put everything in main. Normally what I would do is sort of each of these sections I marked would likely go in their own file. So the model section would go in like a model.hs. The acid state events might go in like acid.hs. The route type would probably go in url.hs. I'm not sure where these would go. They would go somewhere. Just say they might go in types.hs. Usually applications have a lot. I don't know where that would go. Somewhere types. The app template, then I'd usually put in page.apptemplate. And each of these pages I would put in their own file, like page.view, view recent page, etc. And then this I would probably put in main.hs, and this I would probably put in main.hs. So, but you can of course divide things up however you want, but that seems like a pretty reasonable way to split things up for a larger application that's going to grow to have, you know, dozens of pages and a lot more queries and a lot more types and stuff. Like I said, this application is very similar to a bunch of other applications. If you were going to write a blog, you would probably start almost the same way. You would have blog ID, you would have something like format, you would have your blog metadata, and would have a lot of the same fields. If you're going to start your own Twitter clone, your whatever, your own social network, a lot of things sort of start this way. So it's you can sort of start here and go wherever it is that you're trying to get to. That's all for now. And if you have any questions, definitely feel free to ask on IRC, on the Happstack mailing list, on Stack Overflow, or any other place you see us. And we definitely love to hear your questions and comments and feedback, and what you think about this. If you think that there is still too much boilerplate, if you think that, I don't know, what you'd like to definitely hear, what you'd like to see that you liked or didn't like about this. Two things that we did not demonstrate in this. For CSS, we just used an external CSS file. We are looking at also having the option of using a quasi-quoter for CSS so that you can do fancier stuff. We also did not show any JavaScript in this. Right now, the best supported JavaScript option is JMacro, which allows you to embed JavaScript into your HSP templates very easily and splice Haskell values in a very type-safe manner. That's definitely the best way to go if you want pure JavaScript. We are also looking at integration with Fay, which is a subset of Haskell that can be compiled to JavaScript. And that will be really exciting because that will allow you to define shared types between Happstack and Fay. And they'll be for doing communication between the two sides. And so right now, if you want to send values, like if you want to send AJAX values to JavaScript, you have to define a JSON instance, and you have to do all this marshalling to and from JSON on both the JavaScript sides and the Haskell side, and you have to keep them in sync. And if you change your model somewhere, you have to update all that code, and you get no real compile time errors if they're out of sync. With the Fay solution, you'd actually have a file that defines the type in one place that is used by both Haskell and by Fay, so they cannot get out of sync, and you get beautiful compile time errors. So very excited about that. We'll see you next time.